Hi everyone. In this video I'm going to discuss a recommended strategy or an algorithm for solving transient material or energy balances. Similar to the steady state problems or the batch problems that we discussed previously in this course, what I recommend you do in your first step when approaching these problems is you just take time to gather information. Identify what your known information is. Okay? And during this step, what I also emphasize that you look for is you want to identify, what your transient variable is. What do you ultimately want to solve for in the end of the problem? Do you want to solve for concentration, or temperature, or mass, things like that. And once you identify what that variable is, you also want to identify some sort of initial condition, because you'll need this when you're solving your differential equation later on down the line. Okay, so identify what your transient variable is, and also identify the initial condition that's paired with it. After you identify your knowns and what your unknowns are, the second thing I recommend doing is just write out your general balance equation. Whether it's for a material balance or the energy balance. Material/energy balance equation. Okay? And then with that, so write out all the terms. So the material balance, you want to write out A is equal to I minus O plus G minus C. And we'll learn about what, the general energy balance form is later on. Okay? In any case, after you write that, the next step I recommend is you just identify what each of the terms in your general balance equation are. Identify each term, and identify the ones that are negligible. Remove negligible terms. Okay? And so when you do this, you should end up with a differential equation at the end. And up with a... Okay? After that, the next step you should take is you should try and simplify your differential equation so that it is in a solvable form. And so just think back to the previous video where we reviewed how to solve various differential equations. Okay? And then once it's in a solvable form, then go ahead and just solve it. Okay? And during the course of solving the differential equation, you'll also want to apply your initial condition, your IC here, so that you could solve for any unknown constants. And so this would be for the case where you do an indefinite integral. And we'll get more practice by going through the practice lecture problems in later videos. Okay? After you solve for your differential equations and identify any unknown constants, you need to make sure that your solution is actually correct. And so two quick ways to do that. So check to see if solution. Two quick ways to do that is you want to just basically check to see if your solution to the differential equation satisfies the initial condition and also satisfies the differential equation statement. And so basically, if your initial condition said that y was equal to this value at time is equal to 0, what you want to do is take your solution, plug in 0 for time, and see if you get back your initial condition. All right? And if the differential equation you started with said that dy dt was equal to concentration squared, you want to then take your solution and take the derivative of it, and then see if you get back concentration squared. So that's what I mean by seeing if it satisfies the initial condition and the differential equation statement. And you'll see examples of that in later videos. And of course, the last thing you should do is, and I want to emphasize this because the reason we're doing all these transient balances is because we want to see how some variable behaves over time. And so the last thing I'll suggest doing is you want to plot your solution to the differential equation versus time. And in the way I'll set up problems later on in this course, I'll actually just ask you to plot your solution, or sketch a plot of your solution as well. Okay, and so here's my recommended strategy for solving these transient material and energy balance problems.